What's up guys, welcome back to the next video in learning algorithms. My name is QDS Danny and you guys watching my channel Wood. So if you guys notice, we have changed our logo. You guys can leave a comment if you want about our logo, if you guys like our logo or not. Alright, so we begin our next video with running times. What is running times in algorithms? All algorithms has a running times. It means how long it takes to solving a problems. As we said like before in our previous videos, that all algorithms have a running times, and it means how long it takes to solve a problem. So you guys are writing a piece of software, our operating system, our any website, our anything inside the computer, because we all computer scientists, and we're gonna ultimately we're gonna write softwares, and we want to see how long it takes for this our software to run. So, and how long, if there is a problem, how long it's going to take we solve the problem. The running time of algorithms for a specific input depends on the number of operations executed. The greater the number of operations, the longer the running time of the algorithm. So it makes sense, because if your operation is very huge, if you got a very big array of number compared to if you have a very small array of numbers, so it's going to take very less time compared to if you have like big giant array of numbers, and if you want to sort it, and it's going to take a long time. We usually want to know how many operations an algorithm will execute in proportion to the size of its input. Just keep in mind the size of its input, which we will call n. So now you guys memorize this n, because anything we do in algorithms, we're looking for the size of input, and we call this n. So if you have an array of a number, say 10 numbers here, that's the size of your input. The running time of algorithm that searches for a particular element in a list of size n can be expressed as O, and you guys looking here, the parenthesis open n and the parenthesis close. So we're going to write the big O notation, and shortly I'm going to tell you guys what is the big O notation is. So this is the big O. We have big O and big omega and big theta. So we have three. So the first one is the big O. We read this as O of n. So keep in mind, we read this as O of n. This means that the running time of an algorithm is bounded by a function that is proportional to the size of the input. An algorithm with a polynomial running time is considered feasible, while on the other hand, exponential running time one is useless. So if I write a software for you guys and I tell, look, this algorithm takes a polynomial running time, then you just say, all right, that's fine. But if I say it takes the exponential running time, then you're gonna throw my software in and say, I don't want your software, it's useless. As we said, the running time depends, and if you guys look at top, and I said that the running time depends, it depends on a number of factors. The first one depends on input, and we have another input as well, but we're looking for this input. If the input is already sorted, it means that if you guys have an array of the size n, say 20, and your array is already sorted, then our algorithm has little thing to do. Then our algorithm's got like already half of the jobs done, so our algorithm is going to do the another half. On the other hand, it's also again depends on the inputs. If the input is already, if the size of input, which we call n, if n is already sorted, then our algorithm has little things to do. And the second one we say depends on the input size. If you want to sort a lot of inputs, then it takes more time. Then we parameterize input size. So if you got huge giant humongous array and you want to sort it, then it takes a long time. Then the second option is, then we have to parameterize input size. Okay, as I said here, the O of n, we want upper bound for this O of n. So keep in mind, in algorithms, everything we're looking for the worst case running time, and the worst case we denote that as O of n. O is the time, the worst case is upper bound. We're looking, say if you have a graph, and we're looking for the graph, and you're looking for the worst case, and the worst case, it means the upper bound, and we pronounce this as big O, our O of n, so O of function of n. So that's how we write this. So we want upper bound big O On running time, we want time to be no more than the certain amount guaranteed to the user, gives information on program running time. As I said before, if I'm gonna put a say CoreIWOod operating system, and I'm gonna bring it to you all as a computer scientist. I say, look, I have this CoreIWOod operating system, and it takes God knows how long it's going to take. Then it's going to be useless for you guys. Then you guys say, I don't want this, because no one knows that how long this one is going to take to load, or how long it's going to take to process the information. We want the time to be no more than certain amount guaranteed to the user. So the user wants to know that the upper bound. The user wants to know the big O. The worst case, we are interested on the worst case running time. We are not interested in the average case, or say a little bit on average case and the best case, because best case is bogus. It means cheating. Our algorithm has cheated. So we're not looking for the best case, but we're looking for the worst case, which is upper bound, and we denote this as big O. So that's how we're going to pronounce. So we want the time to be a certain amount. If you're going to ask me that you have this software you wrote, and it's got CoreIWOod operating system, if how long it's going to take, and I'm going to tell you the upper bound is big of O is say very fast, and it's say 2 minutes maximum. We're looking for the maximum upper bound. Upper bound is maximum. If I tell you that, look, it's going to take 3 minutes, then it's guarantee. I'm guaranteeing to you. So even you guys say if you have Android phone, and when you start the Android and it takes say 30 seconds, for example, to load, then the Android they guarantee that the uploading time for this device, for this operating system which we call Android, is going to be 30 seconds. So we're guaranteeing that to the user. It means we're giving upper bound to the user, which we denote as a big O, our O, f of n, running time. So that's what we mean by upper bound. All right, so, and I think I have one more slide, and I need to explain to you guys this slide as well. So if it's the time wise, I'm going to look if it's more than say 15 minutes, then I'm gonna split this, and I'm gonna make part 1 and part 2. So just keep in mind, we have a different kind of analysis. In the previous video, I have already explained to you guys analysis. You all should know what I mean by analysis of algorithm. So now we have a different kind of analysis. You guys can connect this to that video you guys want to watch now, because there's this running time, and it's going to be analysis, and we have a different kind of analysis. We usually focus on T of n. You guys see this one is we pronounce as T of n, and T is a time of input size n. So this n, little n, is here, sitting here. You guys normally see this little n instead of bigger n, as I previously showed you guys. And the reason I show you guys, because I just wanted to introduce you guys the size of the input, which we call n. And normally you all see this one as T of n. So T is the time, and n is input size. This is very, very basic of algorithms. T stands for the time, and n stands for input. So that's how we say is time of input size n. So T of n is time of input size n. N stands for input size. And in the previous video, if you notice that I put n in uppercase, is that because I just wanted to introduce you guys standalone n is input size, and if you see this one, the T at the front, it means the type of input size n. So that's how we revolve this. And now we're going to come in this one, we're going to explain this one into, there is a different kind of analysis of time of input size n. And the first ones we're going to see is the worst case, which is usually, that's what we're interested in the worst case. And we define T of n, T is the time of input size n, to be the maximum time, to be the max time on any input of the size n. So we define T of n to be the maximum time on any input size of n, the maximum that is going to cost us. So the T of n for the worst case is the maximum that is going to cost us. And say, as I said to you in the previous video, that I'm going to write software, and I'm going to guarantee to you that it's going to take 3 minutes. So that's max time. I'm giving you guys the worst case. Then I'm guaranteeing to you that, look, I have this Android phone, and I'm going to sell it to you, and this Android phone takes when you start this one, it takes 50 seconds to load. So it means that in the 50 seconds I'm giving you the time frame, this maximum time, and this guaranteed time, and that's how it's the maximum time that is cost us. So it means it's going to cost you the time. We look for the always does rather than sometimes. So it means when I give you this Android, and I'm going to call it, so look, this is my software, it's not a Google's, and it's going to, I'm guaranteeing you, I'm not going to say you, look, it's going to take sometimes it's going to take you 3 minutes, sometimes 5 minutes, sometimes then you say it's rubbish, because you are not giving us the maximum guaranteed time. So we're looking for always does rather than sometimes. So you're not going to tell me that then you're going to turn around to me and say, look, Mr. Yazdani, I'm not interested in sometimes, I'm always. So you're always looking for the worst case. We make no assumption on whether the inputs are coming from, whether what it looks like, beyond what input of n is. So here we make no assumption here. It means that we don't care, or we make no assumption where the inputs come, how it looks like, whatever it is. It says, look, you're giving me this software, and if it takes 50 seconds to load, that's fine by all means, but that's guaranteed. And you guys don't care about anything else. You're not making any assumptions where the input is coming from, what's happening inside the software, whatever happens to the software, you guys don't care, and you're going to leave it up to the developer. And the average case is sometimes, and as I said to you guys, the worst case is usually, because if I write a software to you and I call it say Cryowood Android, then you're going to say, and I give you the worst case guaranteed time, then you guys going to be that the time of size n is the maximum time you're giving me, thank you very much, of the input size n. And the average case is sometime. Keep in mind that sometime, that's not always. Now we define the average case, which is sometime. Now we define T of n to be expected time over all inputs of size n. So this is the expected time of the size n. We analyze the average running time of an algorithm under assumption of different frequencies on inputs. Expected time doesn't mean anything. So sorry for the typo here. Expected time doesn't mean anything. I forgot the S. So just doesn't mean anything. We don't know what is the probability of something is. We need assumption of statistical distribution of inputs. The most common assumption is that all inputs is equally likely. We need to have domain knowledge of the problem. We need some understanding of what inputs are more common than others, what inputs better represents than others. So as I said to you here, this always does and means a lot to us, but here expected time doesn't mean anything. We don't know what is the probability of something is. If you guys know the probability, and if you don't know what is the probability of something, it means it's useless. It doesn't mean anything to you. Even if I come to you and says, I got this software, and my software is expected to load to this time, and I don't know the probability of this, and it means rubbish to you. It means that you don't want this, and it happens sometimes. It's not happening all the time. This happens usually. The worst case, you guys interested on the worst case. That's what I said. This we denote as big O, upper bound. We're looking for the upper bound, and we're not looking for the say average case. We're looking for the worst case. We need assumption of statistical distribution of inputs. The most common assumption is that all inputs is equally likely. We need to have a domain knowledge of the problem. Need some understanding of what inputs are and most common than others, what inputs better represent than others. If I give you a software and if I tell you all this, then it means no good to you guys. You're not interested in any of this. All you're interested is how long my software is going to load and what is the worst case. Best case, and I said to you guys, best case is bogus, is cheat. So if your algorithms gonna go in fast, in algorithm in machine learning, and I'm telling you now in algorithms and machine learning, if our algorithm perform best case, it means cheating. If small algorithm that works best on input, then it means cheat. So even if in the machine learning, if you don't know machine learning, so if I give you the problem of the size n, I give you any number, and I'm gonna tell you guys, look, I'm gonna run the algorithms, and algorithms gonna sort the problem, say the best in machine learning, one is the fastest that algorithm perform. If my algorithm goes in machine learning to 0.99, 0.98, whatever, and the shortest amount of time, then it means my algorithm has cheated. My machine learning has learned a way to cheat. Either it's like you guys going for exam, and someone brings you the exam paper, and give you, and you guys know everything, and when you guys sit on the test, and you're gonna do it straight away because you guys already know all the questionnaire, you guys already know everything. So that's the best case. So if I create a search engine for you, and my search engine always does the best, it means my search engine is cheating. So it means no good. I'm looking for the worst case. I'm not looking for the best case. Best case is bogus. And in machine learning and algorithm, when the best case never happens, and if it happens, it means your algorithm has cheated. So you all need to keep in mind that you guys need to rewrite your algorithm, and you're going to see how your algorithm performs the best, because best case never is a bogus. As a computer scientist, we never believe in best case. Average case sometime, not most of the time, but sometime, and the worst case is usually we looking for the worst case. And the last one, and this is a part one, because my time is getting like nearly 20 minutes. Okay, so, and I'm gonna leave the rest of the next slide on the next part. And the last but not least, you guys see this one, the worst case, average case, and best case 3 in algorithm. But the last one, I thought I better come and share with you guys the amortized complexity. We refer to complexity per run. As the number of runs goes to infinity, this means that the amortized complexity is still good. If sometimes the running time is much longer, and as long as this event is infrequent enough, amortized complexity is total expense per operation evaluated over a sequence of operation. Average time taken per operation if we do many operations. So this amortized complexity is average time taken per operation. This is the simplest explanation. If you all confused here, the last one which I put it here, average time taken per operation if we do many operations. So this amortized complexity is average time taken per operation if we do many operations. That's if we're looking for the average for amortized complexity, and that's the simplest example I can give you. I'll recap. Algorithmic time complexity is a measure of how long it takes for algorithm to complete when there is a change in size of input to the algorithm, which is usually the number of elements of the size n, rather than actually measure the time taken, which varies on the programming language, processor speed, the type of machine we're looking for, even if it's Mac or Linux or any other devices, and 100 other things. Say we're looking for if it's Android or what sort of operating system, what sort of machine you have, if you have a machine from 2000 or if you have a machine in 2022. All things matter. We consider the time to be the number of basic operations that the algorithm has to take. This gives us a metric independence on the user computer. Then we can use to rate an algorithm against other when solving a problem. Okay, so I'm gonna finish this video in part 1, and in the next video, because I'll have a graph and I have a lot of explaining to do, so I don't want to I don't want to give you guys headache. So this video is gonna end now. I'm ending this video, and then the next video, in the second part, we're gonna go on the running times, and I'm gonna show you guys the graph, what the graph looks like, and we're gonna see all the time complexities in the graph. Alright guys, that's it for this video. That's it for the first part, and I'll see you guys in the second part, and bye.